Problem 2. Determine the positive, negative and zero sequence networks for the power system shown below. Assume zero sequence reactances for the generator and the synchronous motors is 0.06 per unit. Current limiting reactors of 2.5 ohm are connected in the neutral of the generator and motor number 2. Okay. So current limiting reactance Xn or Zn is connected to the neutral of the generator and motor 2. So the zero sequence reactance of the transmission line is J300 ohm. Okay. So this is a given power system network. So depending upon the transformers, you have to divide the given network into sections. Okay. So there are two transformers. So we can divide it into three sections. Generator side is section 1, transmission line side is section 2 and the motor side is section 3. Okay. So in this, few reactances are given in terms of the actual units and few reactances are given in terms of per unit. Okay. So when it comes to reactances, you have to use J. Okay. So when it is coming to reactances, you have to use it as J.06, J.1 and so on. Okay. And they haven't mentioned about the common base. Okay. So you just recall the problems which we have solved in module 1. Okay. So initially you have to solve like module 1 problems. So let us choose the generator rating as the common base. So what is the generator rating? 25 MVA 11 kV. So in section 1, MVAB new is 25 and MVAB base KVB is 11 kVB. Okay. So now, since there is a transformer, in section 2, the base values will differ. So based on the transformation ratio of this transformer, you have to calculate the new KVB in section 2. Okay. So for section 2, the MVAB remains the same, which is 25 MVA. KVB is 11 kV, which is section 1 kV. You are moving from section 1 to section 2. Okay. So section 1 kV, which is 11 into 121 by 10.8. 11 into 121 by 10.8, which is 123.24 kV. So coming to section 3. So with respect to section 2, as well as the transformation ratio of this T2, you have to calculate the KVB of section 3. MVAB of section 3 remains the same, 25 MVA. KVB is equal to section 2's KVB, 123.24 into 10.8 divided by 121. Okay, so 123.24 into 10.8 divided by 121, which is 11 kV. Okay, so like this you have to calculate the section wise new MVAB and KVB values. Okay, after finding this, you have to calculate the new per unit reactances of each component. Okay, so now let us go for the per unit reactance calculation, reactances of generator 1. Okay, so here you are concerned about positive, negative and zero sequence network. Okay, so whatever procedure you have followed in module 1, the value of the new reactance is for the positive sequence reactance. Okay, so sequence reactance of generator G. Okay, so we have chosen the generator rating as the common base. We have chosen generator rating as the common base. Okay, so there will not be any change in the per unit value. New X per unit new and X per unit old will be the same. So given in the network, the reactance is 10%. Reactance of generator is 10%. So in per unit it will be J.1 per unit. J.1 per unit. Okay. So generator reactance does not change because generator rating is selected as the common base. So for a generator, positive and negative sequence reactances are the same. So this is all we have discussed in the initial classes, theory classes. So for generator, positive and negative sequence reactances are the same. So positive sequence reactance of the generator denoted by Xg, 1 is equal to J.1 per unit. Okay. Negative sequence reactance Xg, 2 is also 0.1 per unit. Okay. But the zero sequence reactance is given separately. In the question itself, they had given zero sequence reactances of the generator and the synchronous motors are 0.06 per unit. So that is with respect to the old base. But we have selected generator rating as the new common base. Since we are concerned about calculating the reactance, new reactance of a generator, it will not change. Okay. So zero sequence reactance of generator Xg, 0 is equal to J.06 per unit. Okay. But refer back to the notes of the zero reactance generator. So if the neutral is grounded through Xn or Zn, what is the total zero sequence reactance? It is the zero sequence of the reactance of generator Xg naught plus 3 into Xn. So you have to find this Xn in per unit. Okay, so what is this Xn? This is nothing but the neutral reactance or the current limiting reactance. So they had given the current limiting reactor as 2.5 ohm. Okay, so it is current limiting reactor. So it is J 2.5 ohm. So this is the actual value. So find out the base value. Actual by base will give you Xn in per unit. Okay, so how to find the base reactance in section 1? The usual formula, Xn base is equal to kVb square by MVAB. kVb square by MVAB, which is 11 square by 25, 4.84. Actual is J 2.5. Therefore, Xn is equal to J 2.5, which is equal to J 0.517 per unit. Therefore, 3 times Zn is equal to 3Xn is equal to J 1.55 per unit. Okay. So, hope you all understood how to calculate the positives, negative and zero sequence generator of zero sequence reactance of the generator. So, now coming to the sequence reactances of transformer 1. Okay. So, what is the old per unit reactance? 10%. So, you have to calculate the new per unit reactance. So, XT1 new is equal to XT1 old into MVAB new by MVAB old into KVB square old by KVB square new. So, 0.1 into 25 is new MVAB, old is 30. Old MVAB of the transformer T1, 30 into, with respect to primary side, I have written old KVB and new KVB. Primary of transformer T1 falls in the section 1. So, its new KVB is 11. So, we got it as J 0.08 per unit. Okay. Now, for a transformer, positive, negative and zero sequence reactances are the same. So, we write XT1, 1, XT1, 2, XT1, 0 is equal to J 0.08 per unit. Okay. So, we have calculated the new per unit reactances of the transformer, and for transformer, the 3 sequence reactances are the same. So, we have written J 0.08. And remember, in the given question, the transformer secondary is star connected whose neutral is solidly grounded. Okay, so there is no neutral reactance, so there is no need to calculate 3Zn. So, coming to transformer T2, so the specification of transformer T2 is same as that of T1. Okay, so even if you calculate XT2 new, you will get J 0.08 only. Okay. So, XT2 new is equal to 0.1 into 25 by 30 into 121 by 123.24 the whole square. You will get as J 0.08 per unit. Okay. So, now the positive, negative and zero sequence reactances of transformer T2 are J 0.08 per unit. Okay. Now, coming to the transmission line. Transmission line comes in section 2. Okay. So, listen here, whatever they had given in the network, it represents the positive sequence reactance. Okay. So, negative sequence reactance will be equal to the positive sequence reactance. But they had separately given the zero sequence reactance of transmission line as J300 ohm. But J100 is positive and negative sequence, J300 it is zero sequence. But both are in actual units. You have to convert that into per unit. So, for converting that into per unit, what you have to calculate? You have to calculate the base value of the section 2. Okay. So, using the formula KVB square by MVAB of section 2. So, let's calculate that. Yeah. transmission line reactance, base value of the transmission line reactance is equal to kVb square by MVAB2 in section 2. In section 2, kVb square is 123.24. The whole square divided by MVAB is 25. You got it as 607.523. So now the transmission line per unit reactance is equal to J100 by 607.523. You will get as J.1646 per unit. Okay. So this is nothing but XTL comma 1 and XTL comma 2. The positive and negative sequence reactance of the transmission line. Now the zero sequence reactance of the transmission line. Yes, XTL 0 is equal to the actual value of the zero sequence reactance divided by base value. Base value already we have calculated. Actual value it is J300, which is equal to J.494 per unit. Okay. So now coming to section 3, we have two components, motor 1 and motor 2. So for motor 1, you have to calculate the new reactance, which is equal to the old per unit reactance, which is 0.25 into new MVA is 25 divided by old MVA is 15 into old KVB is 10 divided by new KVB is 11, the whole square. So you will get it as J.344 per unit. Okay. Now the positive sequence reactance XM1, 1 is J.344 per unit. Negative sequence reactance will also be equal to J.344 per unit. Okay. Hope all of you are familiar with these notations. XM1, that is positive sequence XM1, reactance of motor 1, comma 1. This suffix represents positive sequence reactance. So suffix 2 represents negative sequence reactance. Okay. But in this problem, they had separately given the zero sequence reactance for the synchronous motor is 0.06 per unit. Okay. So this 0.06 per unit is with respect to generator rating as the base value. Now we have to calculate the per unit zero sequence per unit reactance of the motor with the new common base. Okay. So zero sequence reactance with new base value is XM1, 0 new is equal to XM1, 0 old. This usual formula. What is old value? 0.06. Forget about this 25%. This 25% is for positive and negative sequence reactance. Zero sequence reactance is J.06. So J.06 into new MVAB is 25, old MVA is 15 into KVB old is for this motor 10 divided by KVB new in that section 3 is 11. Okay. So substitute and get the answer is J.0826 per unit. Okay. So be careful about the calculation of zero sequence reactance. Okay. Now look on to the type of neutral. In the case of motor 1, it is left open. There is no neutral grounding. So there is no need to calculate 3Zn for motor 1. Okay. So now coming to this sequence reactances of motor 2. Zero sequence reactances of motor 2. So what is the motor 2 rating? Positive and negative sequence reactances are 25% and zero sequence reactance is 0.06 per unit. So XM2 new is equal to old XM2 into MVAB new by MVAB old into KVB old by KVB new, the whole square. You will get it as J.689 per unit. So this is nothing but positive as well as negative sequence reactances of the motor. So now the zero sequence reactance is given as 0.06 per unit. But we have to convert it with respect to the new base value. So what is the new base value? We know for section 3. Okay. So XM2, 0 new is equal to 0.06 into 25 by 7.5 new MVAB by old MVAB of motor 2 into 10 by 11 the whole square, which is equal to J.165 per unit. But look on to the type of neutral connection for M2. It is grounded through neutral reactance. Okay. So in neutral reactance, in the question they had given current limiting reactance of 2.5 are connected in the neutral of the generator and motor 2. So for motor 2 also the value of Xn is 2.5 actual units. Calculate it in per unit. For that you need Xn base. kVb square MVAB in section 3. In section 3 it is 11 square by 25. 4.84 ohm. Therefore Xn in per unit is equal to J 2.5 divided by 4.84. Okay. So which is equal to J 0.517 per unit. 3 times Xn is equal to J 1.55 per unit. Okay. So now we have calculated the per unit reactances of the generator, the positive sequence and negative sequence and zero sequence reactances in per unit for the generator, 2 transformers, transmission line as well as the motors. Okay. So they had given the neutral reactance for generator and motor 2. Okay. So you have to calculate that 3 Zn for generator as well as motor 2. Okay. And for the transmission line and for generator and the motor, they had given the zero sequence reactances separately. So you have to calculate zero sequences reactances of those components separately. Okay. For transformers, all the 3 sequence reactances, positive, negative and zero will be the same. So now with these values we have to draw the sequence networks. Okay. So first let us go for the positive sequence network. So for the positive sequence network, for the generator, reactance in series with voltage source. For the transformer 1, a reactance. For the transmission line, a reactance. For transformer 2, a reactance. And for motor 1, reactance in series with voltage source. For motor 2, a reactance in series with this EM2. Okay. So now xg1, 1, xt1, 1, xtl, 1, xt2, 1, xm1, 1, xm2, 1, copy down from the data whatever we have calculated, or all the positive sequence reactance values are written in the positive sequence networks. Okay. So for drawing the negative sequence network, what is the difference? So positive sequence reactance and negative sequence reactances will be the same. Okay. So all these values remains the same. The network reactances remains the same, except you have to remove the 3 voltages, e.g. EM1, EM2 is removed. Okay. So this is the negative sequence reactance. See, all the values are the same, but only have shorted the voltage sources. Coming to the zero sequence network, you should be careful in drawing the network as well as in writing down the values. Okay. Already I told you, for the generator and motor 2, we have current limiting reactance, which is nothing but neutral reactance. Okay. So that is 3 into Xn. So for generator I have taken it as Xgn. For motor I have taken it as Xmn. Okay. So that we have calculated J 1.55 and J 1.55. Okay. Now the difference is for the generator and the motor, that is for the synchronous machines, you have to draw the winding zero sequence reactance in series with the neutral zero sequence reactance. Okay. So J 0.06 we have calculated. J 1.55 also we have calculated. Note the difference how we have drawn the zero sequence network for the generator. Then coming for the transformer 1. So transformer 1, for drawing the zero sequence network, you should be very careful about the configuration of the primary and secondary connection as well as the type of grounding of the start point. Okay. So primary is delta, secondary is star with solid grounding. Okay. So now if it is delta, that particular side should be shunt switch closed. If it is star with neutral grounded, series switch of that side should be closed. Okay. So now primary side series switch and secondary side shunt switch should be kept open. See, come here. Primary side in this section D, in this, between these 2 points D and E, we have the transformer. So the primary side, it is left open. Primary side series switch. Primary side shunt switch is closed. connected to the reference bus since it is delta. Okay. Coming to the secondary, it is star with grounding. Okay. So close the series switch on the secondary side and open the shunt switch on the secondary side. And we have calculated the zero sequence reactance of the transformer is J.08. Then coming to the transmission line, zero sequence reactance, it is not same as the positive or negative sequence, it is different. So write down the calculated value. Then coming to transformer 2, between terminals F and G, see the connection, primary is star grounded. So we have closed the primary side series switch and secondary is delta connected. We have closed the secondary side delta switch. Secondary side series is left open. Then coming to the load side, section 3 motor. So motor 1, motor 2. So for motor 1, zero sequence reactance is calculated. Zero sequence reactance is calculated for motor 1. And see, the star is left ungrounded. So you have to leave the neutral reactance place open. Okay. So coming to M2, write XM2, zero sequence component of the motor 2 in series with 3 times this reactance in per unit, which we have already calculated.